Welcome to ETABS 2013, an extremely versatile, powerful, and comprehensive program for the structural analysis and design of buildings. ETABS completely integrates advanced analysis, design, and schematic drawing production in a single program. This means that the user need only create one model to analyze and design the entire building. This tutorial will illustrate the fundamentals of working with ETABS to create a steel building, and will show how quickly and easily a model can be created. At the completion of the tutorial, the building shown will have been created, analyzed, and designed. So let's get started. Our project will be a 4-story building where the first story is 15 feet tall and the remaining stories are each 12 feet high. The bays are all 24 feet by 24 feet, and the lateral system will be steel moment frames. No beam may exceed a depth of 18 inches. We will now start the program. Click the New Model button, and on the Model Initialization form, check the Use Built-in Settings With option. We will use the US customary units, and if we hold the cursor on the information icon, we can see the units that will be used. We will use the AISC 14 Steel Section Database and the AISC 36010 design code. Click the OK button to display the Model Quick Templates form. For most of the templates, this form would be used to specify our grid line data. However, we are going to start our model from a blank screen, so all we will worry about are the number of stories and the story heights. Verify that the number of stories is set to 4, the typical story height to 12 feet, and type 15 feet for the bottom story height. Select the blank button and click on OK. Next, we will enter the horizontal grids. Click the Edit menu, Edit Stories and Grid Systems command. Highlight Grid System G1 and click the Modify Show Grid Systems button. On the Grid Systems data form, click the Quick Start New Rectangular Grids button and verify that the number of grid lines in each direction is set to 4 and that the spacing is set to 24 feet. Click OK. And notice how the X and Y grid data tables are populated. Click OK twice to display the building grid. Next, we will define an auto-select section list, which is simply a list of sections that may be assigned to members. When an auto-select section list is assigned to a member, the program can automatically select the most economical, adequate section. Because we are restricted to a maximum beam depth of 18 inches, it is useful to create an auto-select section list for beams that contains W16 and W18 beams. Click the Define menu, Section Properties, Frame Sections command. And on this form, click the Import New Properties button. On the Frame Properties Shape Type form, click on the I Wide Flange button. And scroll down until you find a W16 by 26. Click once on this section and scroll down further until you find a W18 by 175. And while holding the Shift key, click on this section. Click OK, and the sections just highlighted should appear in the Frame Properties form. In the Model Explorer window, expand the Properties node and then right-click on the frame sections to display a menu. Click on the Add New Frame Property command. On the Frame Property Shape Type form, click on the Auto Select Sections list. Type Autolat Beam for the property name and click on the W16 by 26 in the sections list. Scroll down further until you find the W18 by 175, and again holding the Shift key, click on this beam. Then click the Add button to add the selected beams to the Auto Select list. Under the Frame Sections branch, note that the Auto Lat Beam section is now listed. Click the Define Section Properties Frame Sections command once again, and then the Import New Properties button. Click the Auto Select List button, and then select the A-Comp Beam section. While holding down the Control key, click on the A-Lat column list. These are default auto-select section lists provided by the program for composite beams and lateral columns. Click OK twice to close the forms. Now we will add frame objects to multiple stories. These frame objects will represent our columns and beams. First, make sure that the plan view is active. A view is active when the display title bar is highlighted. You may make a view active by clicking anywhere in the window. Next, click the drop-down box in the lower right-hand corner that reads One Story and select Similar Stories. These options help with drawing and selection. To review these definitions, click the Edit menu, Edit Stories and Grid Systems command. Click the Modify Show Story Data button, and by default the program has defined Story 4 as the master story, and Stories 1, 2, and 3 as similar to 4. This means that with similar stories active, any drawing or selection performed on any one story will apply to all of the other similar stories. We will not make any changes, so click Cancel. Next, draw column objects by clicking on the Quick Draw Columns button. In the Properties of Objects box, make sure that the property item is set to A-Lat Call, which is the built-in auto-select sections list used for lateral force-resisting columns. Click in the Angle Edit box and set the angle to 90 degrees. To rotate the columns 90 degrees from the default setting. To draw the first column, left-click at Grid Intersection D1. Note that the column is displayed over all 4 stories because of similar stories being active. We will add another column at D2. Now change the angle from 90 to 0 and draw the remaining columns in one action by windowing using a selection box. Click the Select Object button to leave the draw mode. And holding down the Control key, click in the plan view on column A2. Select the column in the list. And note that the status bar in the lower left corner indicates 4 frames have been selected. Repeat the process at B2, A3, C3, and C4. The status bar should show 20 frames selected. Click the Assign menu, Frame, Local Axis command, and select the Frame Object Major Direction is Y option. Click Apply, and then OK. The selected columns rotate 90 degrees. Notice that the local axes of the columns are displayed. These axes may be shut off by clicking on the Assign menu, Clear Display of Assigns. Click the Set Display Options button, and then check the Extrude Frame option and the Apply to All Windows option. During development, make sure to save the model often by using the File menu Save command. Next, we will draw the lateral force resisting beams. First, make sure that the plan view is active, and then click the Quick Draw Beams button. In the Properties of Object box, click on the Property Edit box and scroll down to select AutoLat Beam, the auto-select sections list we created and named previously. Left-click once on grid line D between 1 and 2, and note that the beams are created at all levels due to the similar stories being active. Draw beams on grid lines 1 and 2 in a similar manner. Now draw the remaining beams in one action by windowing around the grid lines using the selection box technique. Click the Select Object button to leave the draw mode, and left-click once on the beam located on grid line C. This selects the beam at this location for deletion. Now we will draw the secondary infill beam objects. Once again, make sure that the plan view is active and click the Quick Draw Secondary Beams button. Make sure that the property item is set to A Comp Beam, an auto selection list for composite secondary beams. Left-click in the bay bounded by C, D, 1, and 2 to draw the beams. Draw the remaining infill beams by windowing around the other bays. Next, click the Select Object button to change the program from Draw Mode and go to the Select menu, select Intersecting Line command. Left-click the mouse next to the beams to be selected in bay B, C, 2, and 3, and then move the cursor to the other side of the beams and double-click. The selected beams may now be deleted. Next, we will turn off the extruded view. In this step, floors will be added to the building by drawing floor area objects. Click the Draw Floor button and set the property selection to Deck 1. This is a metal deck with concrete fill. Check that the Snap to Grid Intersection and Points command is active. Click once at grid point A1, and moving clockwise around the perimeter of the building, click at each corner to draw the outline of the floor. After clicking at D1, press the Enter key to complete the drawing of the floor. Note that the two-headed arrow indicates the direction of the deck span. Click the Select Object button to end the draw mode. Next, click the Define menu, Section Properties, Deck Sections command. And with Deck 1 highlighted, click on the Modify Show Property button. We will modify the slab depth TC to 3 inches. Now we will add exterior cladding that has no mass or stiffness to the model to be used for the application of the wind load. With the Plan View active, click the Draw menu, Auto Draw Cladding command. Different objects may be used to define the layout of the cladding, but for our model we will use the floors. Here, cladding is added to the perimeter of the building as defined by the edges of the floors. Changing the plan view to an elevation, we can right-click on the cladding and see that neither stiffness nor mass are being added to the model from the cladding. This cladding will be used solely for the purpose of applying wind loads. We will now change the elevation view back to a plan view. In this portion of the tutorial, we will apply vertical and lateral static loads to our model, consisting of dead, live, earthquake, and wind. The loads to be applied are as shown. The program will automatically calculate the ASCE earthquake load and the ASCE wind load. Start by clicking on the Define menu, Load Patterns command. Note that there are 2 default load patterns, dead and live. Click on Live and select Reducible Live from the Type drop-down menu. Click the Modified Load button to change to a reducible live load. Click in the Load box and type a new name, SDead, for Superimposed Dead Load, and select Super Dead for type. Click the Add New Load button. Repeat this process for a load named cladding. To define the ASCE 7-10 earthquake load, click in the load box and type EQY, and select Seismic for load type. Make sure that the self-weight is equal to 0. And from the Auto Lateral Load pull-down, select ASCE 7-10 and click the Add New Load. With EQY highlighted, click Modify Lateral Load. And on this form, uncheck all but the Y direction checkboxes. To define the ASCE 7-10 wind load, click in the load box and type Windex, and select Wind for the load type. Click ASCE 7-10 from the Auto Lateral Load menu and press Add New Load. With Windex highlighted, click the Modify Lateral Load button and select the Exposure from Frame and Shell Objects option, and then check the Include Shell Objects. Type 100 into the wind speed box, and then click OK. Next, we will assign the gravity loads to the model. Make sure that the plan view is active and that the Similar Stories option is selected. Click anywhere on the deck in between beams to select the deck. Click the Assign menu, Shell Loads, Uniform command, and select SDED on this form. Type 35 and note that the load is applied in the gravity direction. Click the Apply button, and this will apply the load but leave the load assignment form open. Again, click anywhere on the deck but not on a beam, and this time select Live from the Load Pattern drop-down list, and enter 100 for the load. Click the Apply button, and then the Close button. Next, set the Snap to Grid option to off, and select the perimeter beam along grid line A between 1 and 2. Note that 4 frames have been selected due to the Similar Stories option. Select the other 13 perimeter beams in a similar manner. Once all the perimeter beams have been selected, click on the Assign, Frame Loads, Distributed command, and choose Cladding from the load patterns. Using kip feet units, assign a value of 0.25 to the Uniform Load option. With the Plan View active, click on the 3D View button. This displays the loads that were just applied. Click the Assign menu, Clear Display of Assigns to remove this load display, and then return this view to a plan view using the Plan View button. Now we will create a developed elevation view of the right side of the building so that a wind load may be applied to it. Start by clicking on the Draw menu, Draw Developed Elevation Definition command. Type right in the edit box for our elevation name and click OK. Turn the Snap to Grid Intersections command back on, and working in the left-hand view, click once at grid D1. Then moving counterclockwise, click at D2, B2, B3, C3, and C4, in that order. When all the points have been clicked, press the Enter key to finish the developed elevation drawing. The developed elevation displayed is an unfolded view of our right elevation. It is indicated on the 3D plan by the cyan colored lines. Now return the elevation view back to a plan view by clicking on the Plan View button. Next, we will assign wind loads to 2 sides of the building, utilizing the developed elevation just created. Typically, wind pressure coefficients are applied to the vertical surface of an area object, generating load in the local 3-axis direction. Set the 3D view as active, and click on the View menu Set Display Options command. On the Object Assignments tab, set the Local Axes option to On for shells, and click OK. Note, for the cladding along grid line A, the 3 or blue axes point in the negative X direction. Click the Rotate 3D View button and spin the model around to see the other side of the building. Confirm that the 3 axes are in the positive X direction for this side of the building. Through the Set Display Options command, uncheck the Shell Local Axes checkbox and click OK. With the 3D view active, click on the Elevation View button and select A. Draw a selection box around the entire elevation to select all of the area objects, and click the Assign menu, Shell Loads, Wind Pressure Coefficient command. Make sure that the load pattern is Wind X and set C sub P to minus 0.8. Make sure to use the negative sign so that the load will be in the positive X direction. Also make sure that the windward option is selected. With the elevation view still active, click on the Elevation View button once again, and this time select Right. Click once between grid lines 1D and 2D, once between 2B and 3B, and once between 3C and 4C to select the cladding with an X face. Pull up the wind pressure coefficient form once again, and this time set C sub P to a positive 0.5, and check the leeward or sides option. Click the Clear Display of Assigns command and return the elevation view to a 3D view. Now that all the loads have been assigned, we will do a quick review of some of the loads utilizing the Model Explorer. Click the Tables tab in the Model Explorer window and expand the tree under the Model branch. Expand Loads and then Applied Loads, and right-click on the Shell Loads to see a context-sensitive menu. Click on the Show Table command to display the Shell Loads uniform table. Each row in the corresponding table represents one floor object. Note that the fourth column displays the load pattern, and that the last column the applied load. Close the window displaying the table by clicking on the Close button. Now we are ready to analyze the ETABS 2013 model, which we can do by clicking on the Run Analysis button or through the Analyze menu Run Analysis command. When the analysis is complete, the program automatically displays a deformed shape of the model, and the model is locked, preventing any changes that would invalidate the analysis results. In this step, we will graphically review our analysis results. Make sure that the 3D view is active, and click on the Elevation button and select 1. Click the Display menu, Force Stress Diagrams, Frame Forces command to generate member force diagrams. Select the dead load case, moment 3-3, uncheck the Fill Diagram option, and check the Show Values at Controlling Stations diagram and click OK. On the moment force display, right-click on a beam to bring up the individual diagrams. Note that the loads, shear, moment, and deflection are shown. Click the Scroll for Values option and enter 6.5 in the location box and hit the Enter key. The corresponding values are displayed. You may also scroll along the member to any location. We will reset the view by clicking on the Display menu, Undeformed Shape command, and then the 3D View button. Now that the analysis is complete, we can start the design process, starting with the composite beams. In the plan view, right-click on one of the secondary beams. Note that on the Design tab, the design procedure has been assigned composite beam due to the fact that the beam lies in a horizontal plane, the ends are pinned, and it is an I-shaped steel section. Review the information on the other tabs, and then click Cancel. Click the Design menu, Composite Beam Design, View Revise Preferences command. And make sure that the design code selected is AISC 360-10. Review the information on the other tabs and click OK. Set the 3D view to active and click on the Set Display Options button. On the form, uncheck the Object Fill box as well as the All Null Shells box and apply to all windows so that it will be easier to see the frames. To start the design process, select the Design menu, Composite Beam Design, Start Design command. The program will design the composite beams, selecting the optimum size for each from the AComp Beam Auto Select Sections list. When the design is complete, the selected sizes are displayed on the model. Click the Design menu, Composite Beam Design, Verify Analysis versus Design Section command. The message displayed indicates that the members selected in the design phase differ from those used in the initial analysis. In the initial analysis, the program used the medium section by weight from our list, which is different from those chosen in design. Subsequent analyses will use the sections from the current design. Our goal is to repeat the analysis and design procedures until the members in both are the same. Select No at this time to continue our iteration. Right-click on one of the composite beams in the 3D view, and you will see that the analysis and design sections are not the same. The acceptable sections list shows all the members that are adequate for the design criteria. Click on the Details button, and the design report displays all the design information about the beam. The report may be sent directly to a printer or saved as a Word document. To rerun the analysis using the members just selected in design, select the Analyze menu, Run Analysis command. After analysis, again choose the Design menu, Composite Beam Design, Start Design command. Once the members have been designed, click on the Design menu, Composite Beam Design, Verify Analysis versus Design Section command once again, and note that now all the analysis and design sections match. As a final check, select the Design menu, Composite Beam Design, Verify All Members Passed command, which shows that all members have passed the design check. Click the Select All button to select all the objects in the model. Select the Design, Composite Beam Design, make Auto Select Section Null command, and click OK to remove the Auto Select Section List assignments and replace them with the current design sections. Click the Clear Selection button to clear the selections. Next, we will design the steel frame portion of our building. Click the Select menu, select Properties, Frame Sections command. And on the form, highlight Autolat Beam. Click the Select button, and then the Close button. This selects all of the lateral force resisting beams in the model. Click the Design menu, Steel Frame Design, Lateral Bracing command. Select the User Specified option, and then click the Specify Point Bracing button. Here we will specify bracing of the bottom flange at the quarter points. Make sure that the plan view is active and right-click on a lateral force-resisting beam on one of the grid lines. Note that the design procedure is steel frame. Change the 3D view to active and start the design by selecting the Design menu, Steel Frame Design, Start Design Check of Structure command. The initial design is complete, and this form indicates that the design sections chosen differ from those of the initial analysis, which were simply the median weight sections from the auto-select list. Click No to close the forms. Change back to the plan view and click on the Design menu, Steel Frame Design, Display Design Info command. Make sure that the PM ratio is selected, and in the plan view, right-click on a primary beam to bring up the steel stress check form. Note that the analysis and design sections are different. Also note that the program automatically generated code-specific design load combinations. Close the form and select the Design menu, Steel Frame Design, select Design Combinations command to review the design load combinations. Highlight one design combo and then click the Show button to see the cases that make up this combination. Run the analysis once again with the new design sections. And then rerun the design. Again, a few analysis and design sections still do not match, so we will rerun the analysis design cycle once more. We will now verify that the analysis and design sections match. If they had not, we would need to perform the cycle once more. We will also verify that the design is adequate. This concludes this tutorial.